I think this is the first question on the second exam in the fall. So we have this series, and I'm sort of being vague here on purpose. So the lower limit, a lot of times we'll see something like starting at k is equal to 1. And for a series, the upper limit is always going to be infinity. But the point is, we're given what the partial sum is. And no matter what the beginning thing is here, the sum, or the sum of an infinite series, so let's say I have an infinite series like this, and again, it doesn't really matter what this is. The definition is all the same. This is equal to the limit as n goes to infinity of the partial sums, that is the sum k equals 1 to n ak, and as long, whatever the number is there, that's the number that's going to be there. But other than that, otherwise the definitions are the exact same. This is the limit as n goes to infinity. By definition, this is the nth partial sum, Sn. Okay, and this is, what we've written here is just the definition of the sum of a series. This is, by definition, it is the limit of the partial sums. And for this problem, we're given what Sn is equal to. So we don't have to compute anything. We don't have to do anything to compute Sn. We're given Sn already. So for this particular problem, the sum of the series is the following. Let me switch colors here. So for this particular problem, the sum of the series is the sum k equals 1 to infinity ak. We're given no information about ak. That's not needed because we have what the partial sum is equal to. This is equal to the limit as n goes to infinity of Sn, which in this case is 7n squared plus 5 over 5n squared plus 2. Okay, so we've got an infinity over an infinity form here. So I'm going to divide the top and bottom by n squared. L'Hopital's rule is also okay for this one. Okay, so if I divide the top by 7n squared, I'm going to get 7 plus 5 over n squared. And then the bottom, I'm going to get 5 plus 2 over n squared. As n goes to infinity, this goes to 0, and this goes to 0, and this goes to 0. So overall, this is just equal to 7/5. So the answer to this problem is 7/5 because the partial sum, the value of the series is equal to the limit of the partial sums. That's what, just by definition. And we're given what the partial sum is for each n. This is what it is. So we take the limit of this as n goes to infinity to get 7/5 over here.